Inference latency dictates system architecture. Serving Scikit-learn models requires robust, asynchronous handling of concurrent requests. FastAPI delivers this using Starlet and Pydantic. We bypass traditional WSGI bottlenecks by leveraging ASGI, specifically Uvicorn, which handles thousands of requests per second efficiently. Pydantic integration is critical. It enforces strict data contracts for incoming feature vectors, preventing runtime errors before the model even sees the data. This validation step is non-negotiable for production stability. We will implement a structured approach, starting with dependency management and model loading. Start by defining the environment. We require Python 3.8 or higher. Install the core dependencies using pip, FastAPI, Uvicorn, Scikit-learn, and Joblib for model serialization. Joblib is preferred over standard pickle for large NumPy arrays often found in Scikit-learn pipelines. Create a virtual environment to isolate these packages. The application structure begins with a main Python file, for example main.py, where the FastAPI application instance is initialized. We instantiate FastAPI using app equals FastAPI parentheses. This object will manage all routing and middleware. Production systems must load the model artifact only once at startup, not per request. We use joblib.load to deserialize the pre-trained Scikit-learn pipeline or estimator. Store the loaded model object in a global variable, ensuring it resides in memory for rapid access. If the model file, say model.joblib, is large, this initial loading phase might introduce startup latency. Implement a try-except block around the loading process to gracefully handle file-not-found errors or corrupted artifacts. This prevents the entire service from failing before it starts accepting traffic.
Data validation is handled by Pydantic BaseModel classes. Define a class, for instance, feature vector, inheriting from base model. Each required feature becomes an attribute with a specified data type, such as float or integer. Use field constraints like minimum equals 0 or maximum equals 100 to enforce business logic boundaries on the input data. This automatic schema generation is what FastAPI uses to create the interactive documentation. For models requiring multiple features, structure the input as a list of these feature vector objects if batch prediction is needed, or a single object for real-time inference. The prediction endpoint must be a post request, accepting the Pydantic model in the request body. Define the route using the decorator @app.post, specifying the path, for example, /predict. The function signature must type hint the input parameter using the Pydantic class defined previously. For instance, async def predict data : feature vector. FastAPI automatically handles the JSON parsing and validation against the feature vector schema before the function body executes. If validation fails, FastAPI returns a standardized 422 unprocessable entity response immediately. Scikit-learn models require input as a NumPy array or similar structure. Inside the prediction function, convert the validated Pydantic object into a list of feature values. Use the model.dict method to extract attributes, then convert this dictionary into a list of values. Reshape this list into a two-dimensional NumPy array using numpy.array and reshape 1, -1. This structure is mandatory for the model.predict method. Execute the prediction and extract the result. Return the prediction result, typically converted back to a standard Python float or integer, which FastAPI serializes back into JSON.
Deploy the application using Uvicorn. The command structure is uvicorn main:\app, specifying the module name and the application instance name. Crucially, use the -- reload flag only during development. Remove it for production. For high concurrency, configure the number of worker processes using the -- workers flag, typically set to 2 times the number of CPU cores plus 1. Bind the service to a specific host and port, usually 0.0.0.0 and port 8000, ensuring external accessibility within the containerized environment. FastAPI automatically generates interactive documentation based on the OpenAPI specification. Access the Swagger user interface by navigating to the base URL followed by /docs. This interface allows immediate testing of the /predict endpoint. Use the Try It Out button to input sample feature data conforming to the Pydantic schema. Observe the response codes. A 200 status confirms successful inference, while a 422 status indicates a schema violation, providing detailed error messages about the failed field validation. For production readiness, containerization is mandatory. Create a Docker file based on a slim Python image. Copy the application code, the requirements file, and the serialized model artifact into the container image. The Docker entry point executes the Uvicorn command with the appropriate worker configuration. For scaling, deploy this container image onto a Kubernetes cluster, managing horizontal pod autoscaling based on CPU utilization or request queue depth. Implement health checks on the /health endpoint to ensure the load balancer routes traffic only to fully initialized instances.